Welcome, folks, to another one of our virtual tours of outer space. I was going to say good afternoon, but it sounds like some of you are tuning in from other time zones, so could be good evening, good morning, good day. My name is Josh, as I may have mentioned. I'm from Morrison Planetarium. We are very excited to be doing this virtual tour of outer space because it is a very different program than the other ones we do, because I don't get to decide where we go, you folks do. So if you've got an awesome idea of where we should be visiting, I would love to hear it. Drop it in the chat. We had a couple holdovers from last week, so if I didn't go to your requested spot last time and you feel miffed about that and really want to go there this time, make sure you drop it in the chat early and we will do our very best. So we are starting relatively close to home. Some would say in our own solar system. I would raise issue with that because we are hanging out here next to one of our solar system Voyagers. In fact, this is Voyager 1. It didn't just voyage in our solar system. Voyager is actually its name. These were spacecraft created to do what was called the Grand Tour, to fly past all the planets of our solar system and then zoom on out of here. Now, when they flew past all the planets of the solar system, that was really only Voyager 2. Voyager 1 took something of a different route. It swung past Titan, one of my favorite moons, and then couldn't quite get back to the same angle as it would need to visit Uranus and Neptune, meaning that only Voyager 2 really got to visit those worlds. But because it took this funny angle and zoomed off the plane of our solar system, check out this amazing view. It kind of is looking down onto the disk of our solar system. So you can see those blue lines there off in the distance. Those are the simulated orbits of the planets as they travel around the sun. Contrary to how we and many other planetariums always depict the solar system, it doesn't have a wire framework showing the orbits of the planets. They are quite invisible. They're just showing you the paths the planet take around the sun. So we had a request I saw pop up, probably one of the ones I neglected from last week, to see a cluster of stars and to see the Andromeda Galaxy. Well, for that, before I take us in, like I was going to, I will take us out a little bit farther from home. So we are seeing now the true brightness of our sun with respect to the other nearby stars. For clusters of stars, we could look in a number of directions because it turns out clusters are actually pretty common in the universe around us. For example, we have two relatively vivid ones popping out here. You can see in Taurus, this pokety guy right here, that V of stars, there's a cluster called the Hyades. And right next door is a cluster called the Pleiades. Pleiades and Hyades, I believe, are both open clusters. That means they are young stars, all gravitationally bound together, flying through the universe. Now, I'm going to try something of a trick shot and see if I can't get us a little closer to one of these star clusters. Cool thing about star clusters is they actually are relatively coherent. They stick together very closely, and because of that, you can find them spatially. So I'm going to guess this right here is the Hyades that we are flying through as we speak. Now, this is a guess. I had to do my geometry exactly correctly to get us there, and I will tell you, I only got like a C in geometry. So it's possible we are off by a little bit, but given the color of the stars, I'm inclined to think that was the Hyades, and over here, not too far away, I would say this is the Pleiades. Now, a really cool thing about the Pleiades and Hyades, because they are so densely packed, people are pretty good at recognizing them, especially the Pleiades. So Pleiades has a ton of names for different cultures around the world because so many other folks have recognized it as a thing, a unified group. In fact, one of the oldest depictions of an astronomical view of the night sky is what's called the Nebra sky disk. It was found in Germany, I believe, by some probably tomb robbers. And it is a bronze disc depicting the sky with a crescent moon, what we think is probably a sun or else a full moon. There's some varying interpretations of it, but it is an immensely cool object. And if you want to check it out, that has a depiction of what we think is the Pleiades on it. I would say relatively confidently, it's got to be one of the oldest depictions of the Pleiades we've got. There are some cave art versions, though, that show off the Pleiades too. So Crystal wants to know what the big black cloud is. Oh my gosh, Crystal, excellent observation. Big black cloud. My first question would be, which big black cloud? Because you can see a lot of big black cloud, right? Looks like something spooky creeping up on us. Well, that is in fact the galaxy itself. So what we see as big black cloud actually has a very scientific name, which is nebula. What does nebula mean? Cloud. So this just is what scientists call the big dark cloud, the absorption nebula. So these dark nebula features are where gas and dust is between us and the bright center of our galaxy. That kind of blocks our view. If I pull out, we can see our super cool computer-generated model of the Milky Way itself. If you imagine all these bright lanes of gas and dust, well, they're bright because of stars that reside within them, but they also have that dark material inside them as well. And from where we are, out in the outskirts of our galaxy, some would say sort of the not desirable neighborhoods far away from where all the cool stuff is happening, well, that's where we live. And all of this cool stuff in between us and the center of our galaxy is blocking some of that light. It's actual physical material that absorbs some of the light coming to us from the center of our galaxy. And because that light is absorbed, it doesn't reach us, we see it as dark. However, if we change the color of light we're looking at, and we look at something that is where cool gas is actually emitting light, like radio, well, then that stuff is very bright. And the stars themselves are not quite as bright, which is a very interesting inversion of the universe we're used to. Now we can see a couple dwarf galaxies hanging out nearby. These are the smaller and larger Magellanic Clouds. They are dwarf galaxies actually bound to the Milky Way itself gravitationally. Kat wants to know, is our galaxy moving through space? Oh, that's a tough question to answer. I will say it depends entirely on what physicists love using, which is your frame of reference. So if you live in another galaxy, yes, the Milky Way is absolutely moving. But we've decided that we are not moving and everything else in the universe is moving. I like to think of it as if you're driving down the street in your car. It's very easy to pretend in your mind that your car isn't moving, everything else is flying past you. That's kind of what we're doing. We're using our frame of reference as our own galaxy. We're pretending if our galaxy moves not at all, how much does everything else move? So looking around here, stars are flying through space. I thought stars were stationary like our sun. Ooh, wonderful lead-in. I think Mary has an idea here. It all depends on your frame of reference. We often imagine our sun is stationary because our planet is going around it and the sun makes a handy frame of reference. But it turns out that's only from our star. From any other star, our star is moving. And from the frame of reference of our galaxy. So if we use our galaxy as something of a stationary point, we imagine all of these stars are moving around the galaxy. You can kind of imagine that. There's actually, I'm going to see if I can find it because it looks so cool, but galactic year. There's a path the Milky Way, or path the sun takes through the Milky Way is just the coolest thing ever, especially being able to see how our sun travels through the Milky Way. So that is definitely something you can turn on in OpenSpace. If I didn't mention it before, I'm using the software OpenSpace, and it's one you can actually download and use for yourself in a super cool way. Star orbits. Is that it? Yes! I found it! So check this out. These yellow paths are showing us where the sun is over the course of what we call a galactic year. In fact, these are all the orbits we expect our sun has taken over the sun's entire 4 billion, 5 billion, let's call it, year existence. So it takes us about 200 million years to go around the galaxy once. So I guess these 5 or so orbits would be the past billion years of our sun's position. And you can see where we ended up today. So 200 million years is a long time to make one trip around the galaxy. I always like thinking, if you imagine the dinosaurs' age, I think that ended, 66 million years ago? And if it takes us 200 million years to go around, well, then 66 million years ago, we would have been like, I don't know, here? About a third of the way through the trip? So the dinosaurs existed in a totally different part of the galaxy than we did. Isn't that a crazy thing to think about? I love that idea. That this dinosaurs lived over here, we live over here, or at least given some frame of reference, but the galaxy has moved that much over the course of 66 million years. So yes, stars are moving, everything is moving given some frame of reference. That's really a tricky part of physics and one that gets physicists out of some very challenging questions. For a given frame of reference, you can make anything you want equal 0, and that makes the math a lot easier. Okay, let's see. What do we got going on? Any fun questions popping up? Are stellar clusters as viewed from Earth simply in alignment from our view in outer space, or are these clusters truly close to one another? Daniel, both. That's another tricksy answer. Sometimes we see stars that look like they are very close together from our perspective. I'm going to ask Mary to put on my camera for 1 second. So if you imagine I've got one star here and one star here, and we're looking at them from Earth, they could appear pretty close together. The challenge is they're actually very far apart. But sometimes we see stars that appear close together because they are in fact close together. That's what we might call a binary. The other ones we call optical binaries, which means they look like binaries, but they're not actually two stars very close together. Thank you for the camera view, Mary. So when we're looking around here, when we see a cluster of stars like the Pleiades or the Hyades, those are families of stars that were born together and are actually bound together gravitationally. When we talk about just two stars that happen to appear together close in the sky, it could be at a huge distance apart. I would point you towards a very cool pair of stars called Albireo. If you want to see some that are actually in the sky, right when the sun comes up, part of the summer triangle, you can actually see them these days and get a cool view. I only know that because my dog has decided that 4:30 is a totally acceptable time to go for a walk. So I've been getting up at 4:30 in the morning. I honestly can't recommend that. It's best avoided. But if you are up at 4:30, go check out Albireo. It is a really cool optical binary. I think last I heard, they were not actually gravitationally bound together, so they look like a binary even if they're not. Okay. Let's see. Oh, good question from Maddie. If the sun takes 200 million years to orbit the galaxy, what speed does that infer? So you could take our distance from the center of the Milky Way, which is about 30, some people say 35,000 light years. And you could multiply it by 2 pi, I believe, to get a circumference. And then you would have the distance you would need to go all the way around. You could divide that by 200 million. Sounds like somebody's already doing the math. My best way of solving that is to go to the Monty Python song, which is describing how fast you're moving through the universe. But I don't think their numbers are precise, so I'm going to refrain from trying to do that in my head. Okay, let's see. Dwarf planets other than Pluto. Oh, Diane, good calling me out on always going to visit Pluto, because I think Pluto's cool. Let's see what other dwarf planets I can offer you. I know we have at least one other, so let's see if we can make this happen. Avoiding the planets, going to the dwarf planets tab, I think the only other one I can offer you is Ceres, but that's not a consolation prize. Ceres is an awesome place in its own right. So my favorite thing about Ceres has kind of been ruined because I just said where we're going. But to ask people if they want to go visit a dwarf planet that used to be a planet that was demoted to dwarf planet and make people think that they're going to Pluto, but then take them halfway between Mars and Jupiter where Ceres is hanging out. Ooh, so we figured this out before. If we want Ceres to show up correctly, I'm going to go to my layers and turn on some of these guys. Okay. So hopefully this fixes in a second. You might have noticed Ceres looks kind of like a egg that's kind of bumpy and weird shaped. There we go. We got some texture on it. So these guys, this is the one I like the best. You can turn on all sorts of cool data in OpenSpace and get it really to the point where you want it, but there are so many options. Sometimes when I'm flying around, I poke the wrong one. But looking around here, check out this topography, the height, the change on the surface. When you look around on Ceres, you can see all sorts of cool stuff. However, there is one specific place I would love to show you that has some really cool features. And that looks like it is on the night side. So let me see if I can turn off our nighttime. There we go. So on Ceres, we thought for a long time it was going to be a rocky world with maybe a little bit of ice mixed in. That was a good guess because we see a lot of other similar objects that have an icy component, and Ceres has this really bright spot right here. But recently, very recently, I think just a couple of years ago, proof was offered that Ceres was not just slightly icy, but actually is probably one of the most water-rich bodies in the whole solar system. And that's fascinating. So there's probably a ton of water inside Ceres, which is tremendous. That's a really exciting thing. Another potential reservoir of water in our own solar system is a huge deal. And in some spots, we can see evidence. Aha, I found it right over here of that water coming up to find us. So check this out. This is got to be one of my favorite, gosh, how would you say that? Sarian features? Sarian? But right here, you've got like opposites. Sticking out on the surface is an ice volcano, and right next to it is an almost equally sized crater. So to me, for just an imagination's sake, I like to think that if you chopped off that ice mountain, you could drop it in the crater and kind of average out the surface in a really fun way. But check out this ridiculous ice mountain. When we drop down to the surface, it looks like if somebody who can't draw, like me, tried to draw a mountain. It's just a big jagged thing sticking out of the surface. Well, turns out gravity is so insignificant on Ceres that you can build very tall, very steep mountains. Having a low coefficient of gravity makes it so that you can balance things on top of each other very, very easily. So looking at this thing, that's a mountain. That is, we think, an ice volcano. And right next to it is a crater. Totally unrelated, probably was there well before. But this is a dramatic and interesting place. We had folks talking about how big is this thing. It's really small, really, really small. So we often try and throw out sort of a state size comparison. Ceres, I believe, is about the same size as Texas. If I recall correctly, you could drive from one side of Ceres to the other in slightly longer than it would take you to drive across Texas. However, it would probably take you a lot longer because Texas is broad and flat and has big highway systems. Roads on Ceres are hard to come by. And plus, every time you hit a bump, if you were going fast enough, you'd probably reach escape velocity and just fly off the surface of this little world. It would not be an easy drive. So this is a tough environment. We had a question coming about what happens to cause the change from a dwarf planet to what we call a major planet. Cat, that is entirely a semantics argument. You get people from the International Astronomer Union talking about whether or not something should be a planet and seeing which category it's closest to. However, I will offer the opinion of many planetary scientists on this. Astronomers study the entire universe. They study stuff from the formation of stars to the age of galaxies to the structure, the cosmological implications of the universe. Maybe they're not experts on what makes a planet a planet. Many planetary scientists think that their opinion should be the one that matters most on whether or not we call something a planet. And all I can say is that's currently a disagreement in the scientific community. What I can offer you is the context for why they decided Ceres wasn't a planet. And that's because Ceres is one amongst legion. It turns out there are a ton of objects around Ceres. I'm going to see if I can turn these guys on. Right where Ceres is in the solar system, there are tons and tons of asteroids. So Janet wants to know, why is Ceres not a large asteroid? It is a large asteroid. Someone put forward a fun mental puzzle. We often say Australia is Earth's biggest island. We also say Australia is a continent. Is Australia a continent or an island? I think it's maybe both. So Ceres is the largest asteroid, and it is a dwarf planet. I think it's both. You don't have to exclude one to be the other. Same way we could say that Pluto is the largest Kuiper Belt object. It is an object in the Kuiper Belt, so that's an easy one. But it is a dwarf planet as well. So looking at all of this, let's call it complications that exist around it, this is only one family of asteroids. We also have our Amor, we have our Aten. There's tons of asteroids in the asteroid belt, and Ceres is just nestled amongst them. There's also big objects like Vesta, Hestia. There's big things out there that occupy a similar space. So part of why we've decided that it's not a planet but a dwarf planet, this is because of the stuff around it. It hasn't cleaned up its room well enough. There's still a lot of stuff laying on the floor. That's a lot of things in its area. I see a bunch more questions coming in. One from Michael. How big would an asteroid have to be to knock the moon off its axis? Probably not very big. In fact, we think there's evidence of impacts on the moon that probably shifted its axis long, long ago. One of them formed one of the biggest impact craters in our solar system. That is the South Pole Aitken Basin. So I'm going to take us in real fast to that. But then I had another question. How many craters can scientists estimate the moon has? Oh boy, that is a tough one because the smartest scientists don't have time to do that. But they've set computers to doing it for them with the help of a lot of citizen astronomers like you and me, and grad students. And they have worked hard to figure out how many craters they can see. But the problem is, every time you look closer at the moon, you see more craters. So you look closer, so you see more craters. So you look closer, so you see more craters. It becomes a very hard problem very fast. So my question would be, how small can something be where we still call it a crater? And if you say just to make a little dent in the ground, that would be teeny tiny. There would be a lot of craters. Okay, so down here, I want to get us to the right part of the moon. South Pole. I believe this is our South Pole. And to see the South Pole Aitken Basin, now this looks kind of like the North. That is the North Pole. Who's flying this thing? Okay, here we go. That's our South Pole. So if I recall, if you want to hear a real expert talk about this, go listen to Brian Day in one of our Cosmic Conversations. But I believe this is one of the crater walls of the South Pole Aitken Basin. Nope, that's it right here. This whole dark area. This is a gigantic crater. So that for sure was big enough to knock the moon off its axis once. Maybe one would hit it again that could be even smaller than that and would knock off its axis as well. But thankfully, we think most of those big impactors have probably already hit stuff here on Earth. There are probably very few of them left, and we're pretty sure none of them are inbound towards Earth. We had a request earlier on that I saw to see Earth up close, and I think that is too cool an opportunity to pass up. Looks like we had a request from Kaylee and Marley to go see Earth up close. Well, right now, I have us loaded up for right now. So I'm actually going to take us to, how does yesterday sound? March 2nd. And when I take us to March 2nd, we're going to pull in a brand new picture because this is a photo taken on March 2nd. So we can see Earth as it was just a couple days ago. So a couple days ago, we can see what the weather was like in Australia. Looks like cloudy on the north side and the western side. We can fly over here to North America. We can see the lights going on over here on the eastern seaboard. And down here, we're coming out of our winter season in not too long. And that means we're actually getting some sunlight on the west coast when we do Cosmic Conversations. So we can actually see San Francisco. Now, I'm going to take us into San Francisco because I think that's always a cool thing to do. And as I do, we're going to fade off our clouds so we can see the surface of Earth a little better. We're going to go down here. You can see the whole peninsula. Moving in towards our beautiful city by the bay. In the bay, sort of. The bay is kind of wrapped around us. And this, to me, is just so cool. So we are bringing in very high-resolution pictures to show us what San Francisco looked like yesterday. And because I haven't been there in a little while, and I think it's a really cool place, I want to go visit the Academy of Sciences. So this is the Cal Academy. We are flying into smack dab in the middle of our section of Golden Gate Park. And as we dive in there, you really do get to see that beautiful living roof, our music concourse, and all the way over here. You might notice as we get closer and closer, these are not photos that were taken yesterday, and I can prove that because there's no giant Ferris wheel, observation wheel over here on Golden Gate Park. Normally it would be right here on this part, and these photos were taken, I think, a little while ago. So they're not quite as up to date as those ones we had taken by the, I think, MODIS survey, the SWOMI, pardon me. That was the ones we see that are very up to date. That's this photo right here. Okay, let's see. Can you see clouds from space? Question from Crystal. So Crystal, this is a photo taken from space where we can see clouds. Really cool thing, we can actually see clouds on more than one planet. Right now, from space, we can look down on Earth and see clouds, but if you wanted to see space clouds from your house, all you got to do is look in the direction of the sun, not at the sun, that's dangerous. But right over here, right before the sun comes up, we should have a glimpse, very tough to see, but it's theoretically possible, glimpse of Venus. Now, when you see Venus, it looks like a bright dot in the sky, but really what we're seeing is light bouncing off Venus's atmosphere, this glow around it, and coming to hit us here on Earth. So that's one example of clouds in space, but it's not the only one. I want to take you out to the cloudiest planet I know, that is Jupiter. I suppose Saturn would be a cloudy planet too. But on Jupiter, we really get to see the clouds changing. We can see dynamic clouds, and to me, that's cooler than just seeing a cloudy surface. Because if you watch Jupiter for long enough, if you went out there with a telescope night after night, you would see those clouds change over time. Sometimes the bands are thicker, sometimes they're thinner. Once upon a time, the bands just disappeared. That was a weird couple months. But when we talk about Jupiter, it is a dynamic planet. It's not a rocky planet like our own. It's what we would call a gas giant. Because it is a gas giant, the surface is always changing. You see storms pop up and disappear. It is a place that is really wonderful because it's so dynamic, but not quite the same kinds of systems we have here on Earth, even though there are maybe some connections. There are convection bands and stuff that moves the atmosphere of Jupiter in similar ways to the atmosphere of Earth moves. So do we have any planets that have blue skies? Cool question from Janet. Well, we've got some planets that are blue. Uranus and Neptune have blue surfaces, but I don't recall. I think actually it wouldn't be the case. If you were looking up from the surface of Uranus or Neptune, that things would look blue. What I can offer you is Mars. Turns out, most of the time when you're standing on Mars, the sky would be sort of orangey, kind of gray. That's a hard color for me to imagine, orangey gray, but that's kind of the best description I can offer, an orangey haze. However, when the sun is rising or setting, and there's dust in the air, if I recall correctly, you would get a chance to see a bluish sky, which just to me sounds like the coolest thing ever. A really awesome detail of people when they're on Mars one day hiking around, instead of seeing a beautiful pink or red sunrise, they might have a chance to see a blue sunrise that tells them that there's dust in the atmosphere. But with that, I think we are very close to time, so I'm going to point us back home. Linda asked a question, does the universe keep going? What lies beyond it? Madison, I'm afraid I have to tell you, the universe does keep going. It's always expanding, but there's always more universe. And that sounds like a really confusing question. Well, sometime soon, when we get back to our museum, we are excited to offer you one of my personal favorite shows that is a tour of the universe, where we get to address that exact question. And in fact, I think very early on in our broadcasts, we've got an example of Tour of the Universe. So if you want to tune in and watch that, check out our listed videos on Facebook, and it might be on YouTube as well. But with that, I'm taking us back to planet Earth. Thank you all for tuning in to our virtual tour of outer space. It is such a joy to get these questions. I wish I could keep up. We had so many today, I was falling behind. But if you have a question that you want answered and I didn't have a chance to answer it, bring it next week. I would love to take another swing. From all of us here at the Academy and OpenSpace, thank you all for tuning into our broadcasts. It really means the world to us. We love doing them, and we are so excited that you tune in to watch. But thank you again, and have a wonderful rest of your day.